Hello, everyone. Welcome to the next and the last session of our Cloud Native Launchpad series. You can find the recording of this session and all previous sessions on our Devon and Beyond Cloud Native page. And while you're there, please take a moment to review the other series and webinars that we have added over there. Our topic today is building or enhancing your CI/CD architecture with OCI DevOps, where we'll explore the core capabilities of OCI DevOps, see how to integrate with tools you may already be using, and evaluate a few different deployment strategies. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle, and our presenters for today are Eli Schilling and Lynn Lewis. And with that, please enjoy the session. Eli, take it forward.
Excellent. Thanks, Renu. So I'm Eli Schilling. I'm a developer advocate here at Oracle Cloud. So appreciate everybody coming out to join us. And Lynn, how about a quick intro from you, sir?
I'm Lynn Lewis. I'm a cloud architect here at Oracle, and look forward to working with Eli and giving you a good presentation that you can use in your business.
Fantastic. Thank you. So as Renu mentioned, we are at the 6th and final session for this series. We are going to be talking about the OCI DevOps tool and some of the cool, nifty features available for accelerating your application delivery in the cloud. I dropped a QR code there on the screen as well. If you missed any of the previous sessions, please snag that and jump out to the Day One and Beyond website where you can view the recordings. And as Lynn mentioned, so in the session today, we're going to go through some key concepts for continuous integration and delivery. Just a bit of a refresher, kind of make sure we're all on the same page in terms of some of the concepts and the methodologies. We'll talk through the various capabilities of the OCI DevOps service and kind of introduce everybody, if you haven't seen it yet, what it is, how it works, and what features and options are available there. We'll talk about some of the third-party integrations that are available as well, and some of the different reference architecture types. One of the really nice things, in the OCI DevOps ecosystem is really the intent is to make life easier, not more difficult. So this isn't necessarily a replace everything you have today with what we're presenting. It's really about looking for opportunities to streamline your continuous integration delivery processes with additional tools that are available to you. And no presentation would be complete without a demo, and we'll do the live demo, cross our fingers, and hope that all those positive vibes for a successful live demo are here with us today. So DevOps, you say. This is always an interesting topic. I feel like I got into it fairly early on, kind of back, well, let me back up just a minute. I actually started back in the day when, we were writing code, doing, quarterly or semi-annual or even annual deployments. And it was really kind of the developers sitting in their cubicles, hammering away at the keyboards for long hours. And then every few months, we'd kind of get together and test things and see how it all went. So in this notion of kind of, speeding up the process, per se, kind of breaking all of not only the process and the methodology down a little bit, but also breaking down the builds and the size of the deliverables that we were creating as part of this development activity, so that we could really kind of streamline and accelerate the process. And you kind of see here, and I'm sure folks have probably seen this graphic 500,000 times or more. But the notion is we kind of kick things off by planning what we're going to be doing, writing some code, build that code, test the code, release the code, deploy the code, and then we're done, right? Right, Lynn? We just kind of deploy and we walk away and we wash our hands.
No, it's an infinite cycle.
Right, that would be very 2009, 2010-ish, I think. So really, we're kind of getting through this process where once we actually get that code rolled out, there's a whole operations aspect, which is where we come up with the term DevOps. We have to basically align and partner with our operations, our SRE teams, to kind of see how things work and function, how they're going to be able to support a functional and efficient application once it rolls into production. We're going to be monitoring all of the resulting functionality, performance, et cetera, to make sure that things are operating as expected. And from that, we're likely to identify whether it's additional feature requirements, whether there's new ways to enhance performance and reliability. We're going to take those learnings back to our planning phase and start this process all over. Oftentimes when organizations may begin this process, this could be a monthly cycle. And we kind of, as we develop and mature, we kind of whittle down the process and we move more quickly. I'm not going to spend a whole lot of time on agile software development, but that's typically, the Scrum process that we align to a DevOps methodology, where we're starting to identify, the planning process is picking out the features and the options and the bugs that we want to fix. We'll go through a sprint, which is typically a 2-week period where we're doing the coding, the building, the testing. We release that potentially at the end of the sprint, identify the next set of items, go back to the planning phase, and we kind of go in this big infinite loop. And for me, I think the really exciting piece here is it's not just technology, it's not just process, it's not just people, it's the appropriate combination of all those 3 things that will implement and will produce a successful DevOps culture within an organization. One of the key tenets, another key tenet here, is really about mitigating the potential for error. I'm sure folks have seen over the years, and I won't point to anything specifically, but there's been some pretty big news over the years about, a software deployment, a manual software deployment gone awry, resulting in, significant downtime, loss of revenue. There was one even back in 2013 or 14 where a company went completely insolvent and disappeared the next day as a result of an error. So we want to try to identify and automate and mitigate as much of these potential errors as possible. But it's interesting because, the more you automate, the potential for error, but that never really makes it all the way to zero, because there's always some other facet that's really involved there. And it's kind of like, the chances of a cat stealing your car is pretty low, but never zero. And I hope everybody got as much of a kick out of that as I did when I saw this picture. So I'm going to pass it over to Lynn. He's going to take us through some of the DevOps service features and capabilities, and talk a little bit more about what we have available to us in the platform. Lynn?
All right, I'm going to start out with a couple of items. First of all, I'm a real believer in documentation and reading the manual, and that comes from over 20 years as a combat crew commander in different aircraft over the years. And my initial development with DevOps was actually with software development for computational fluid dynamics and structural dynamics, primarily better weapon systems through mathematics, and later working with professional companies in the 90s for better automobiles, and as well as better commercial aircraft. But one of the things you'll see with Oracle's documentation is pretty solid. And you can find under application development our DevOps. And then a click on DevOps, you'll see different discussions of it, give you a video overview, can learn about what we're talking with respect to this. Now, one of the things I do want to set right up front is that this is a service. So it's only what resources you use. There's a lot of plugins and capabilities. You can use anything that you want to. It's open. And all we're doing for you is providing the hardware and the structural integrity, so to speak, underneath to reduce those errors and to make sure you have a standard pipeline, standard set of way of saving your artifacts, a standard way of putting things together so you can put things in a position for you to make fewer errors, if you will. And then if you look to, not only do we have the basics with respect to DevOps set right there, right down to the respective policies that you're going to need to do. How are you going to get access to these tools and work with them, and who doesn't have access to them, which in many cases can be just as important. And then you can go here to our architecture center, type in DevOps, and you'll see a whole series of, well, about 20, almost 30 different reference architectures out of 600 that are dedicated to different methodologies and working with CI/CD pipelines, not just ours, but other folks as well. You'll see our partnership with Azure show up here as well. And then you can go to our help center, which is again a learning center with tutorials. Type in DevOps and you'll see some of the labs that we provide for you. Now, many of these labs are to be done in your tenancy, but also you can do them in a free tenancy, or in some cases, will offer you up a free lab. Some of these are very short, 30 and 20 minutes, but some of them are longer, 2 hours. The idea being that you're going to have an opportunity to actually get your hands dirty, so to speak, because you're not going to learn it by reading the documentation. You're not going to learn it by listening to Eli and myself. You're going to learn it by doing it, because that's the only way you're going to effectively try and figure out what really does work for you and what really doesn't work. So that's part of the process. And finally, there are videos right on YouTube. So go into our YouTube channel, Oracle's YouTube channel, you can find a variety of different DevOps presentations. So that shows you that it is primarily automation that reduces the opportunity for error, for letting your thumbs get in the way, and it provides you with the security because you're in OCI, and so you have all the access with security zones and tracking how to get in and out and moving from one cloud to another, and then the governance allowing you to track your issues as well, going from place to place. And the whole idea is to automate the delivery of your platforms, right? So you can deploy to DevOps, you can validate a test, and you can, of course, you choose your own test in this process. You deploy to staging, you have a manual or automatic approval set in place, can have an AI adjusted to it as well, and you can deploy to production. So originally, right, we did this heuristically. We would go through the process, we would see what worked for us or our team, we would go through it a couple of times, and then we'd write rules and or set structures in place so that we would be consistent in our performance going from release to release. Well, now you have the opportunity to start from the beginning to create a series of structures for yourself inside OCI, getting all the security for you and getting that automatic system in place. And this reinforces the fact that it's a service and therefore runs servicely. What that means is, of course, there's servers underneath it. We wouldn't be having to spend as much as we do with respect to for the energy consumption going forward for the number of data centers out there in the world. So there are servers underneath, right? But the way you're going to be charged is not necessarily by the number of virtual machines or the number of storage, but only when you resources stop and complete the jobs and terminate. So everything is only when you use it. And it's going to give you the opportunity of integrate not just into OCI, but to other clouds as well as on-premise or to your own laptop. And then you have your native CI/CD platforms. One of the things that Oracle has really done a good job of has integrated in sort of the Sun DNA, the less proprietary in place and very much more open. So we are very much involved with the cloud standards at this point as well. So you're going to do what you would do with any service. You're going to commit your changes to a particular code repository. You're going to run the build. You're going to test to see if you haven't messed things up. And then you're going to deliver the artifacts to a container registry in place. And then you're going to pull from that to deployment for your integration tests. And finally, your approval. And usually probably you'll be going back at this point and finding some error that needs to be go through the process. But the more you go through this, the least likely you'll have those interruptions in your flow. And what's more important is you won't have interruptions with your customer experience with running the application. And then you have a choice, not just Oracle, but other methodologies. You could even do this now with our service. We do give you OKE for Docker containers, but you could you could set up and modify these scripts to run Podman, LDS. So there's a lot of different LDX, excuse me, there's a lot of different ways you can play with this to fit you. This is just a framework for you to apply with open standard software. So here's an example. Now this is through our UI. Another thing to remember when we show a UI, everything that you can do in our UI, you can do with a REST API call. Frankly, that's what it degenerates into, that's stored as an audit file. But more importantly than that, you can use OCI CLI from your laptop or from your service. You can set up a bash script and run it through and get the information out. The idea being that you can go through here, you have to enter a stage name, you have to enter a description. That's optional. That's more for you than for us, right? And then you can get a custom shape or a default shape. And these things can be essentially very inexpensive. You can even, I'll have to check, I should have before I came on, but I believe you can even get an ARM system at this point. And the reason you might think about ARM is it's the least expensive right now per thread. Memory doesn't change, but the threading cost does. So the whole idea is you have a variety of different release strategies that you can deploy. And the other thing that we provide is our observability and management material. So you could use our application's performance monitoring system, put it into your containers of whatever kind, and deploy them first as simulated in different parts of the world, different data centers of OCI, and then have those be clients that would then, if you will, for lack of a better term, attack your application globally and see how the response times are in different areas based upon the scripts you set up. This is non-trivial. You set up in your clients against your application and see what happens in those processes. So you can really get detailed with these release strategies and integrated with a variety of other services within OCI. Idea is to connect with your workflows, and when things don't work out the way you expect them to, and they won't always, you'll have a way to roll them back in an effective manner, just as we were talking about before. Roll them back, start this process again. It's like anything else in this life. You get to one level and then you better be ready to jump to the next level, because it is a continuous situation that you're in. Eli, do you want to add anything at this point?
Zoom in a little bit. All right. So Lynn's talked a lot about kind of the conceptual nature of the DevOps service. We are just going to jump right into the DevOps projects from the console here. And you'll see right up front, I've got a couple different options, overview of the service itself. That's going to give us some details, some learning opportunities, so we can kind of figure out where we want to start and what we might need to gather before we start plugging in the bits and pieces. But in this case, I've actually created a project which is very straightforward. It's literally a name. We do need an SNS notification service topic. This is going to allow the DevOps service to send notifications. This could be for approvals or other activities if there's a rollback. So we'll set up that topic, and then it's just about, do we want to send an email or a push notification? That's all configured in the topic itself. So that's pretty much it. Creates the project, which is kind of the container for all of our stuff. And if we jump in here, you'll see we've got the code repos, the build pipelines, deployment pipelines, all this nifty stuff. If you recall, a couple sessions back, we did talk about source control or source code management, where we did talk through some of the capabilities with the OCI code repositories. But it is part of the overarching DevOps service. So it's here, it's available, whether you want to create a brand new repo from scratch or mirror an existing repo that GitHub or Bitbucket or GitLab. Makes it easier just to kind of copy or pull that source code in from an existing location rather than starting from scratch if you already have the code there. On the build pipeline side, we have build pipeline already created. And again, these are basically just wrappers. So when I create the pipeline, we just give it a name and we're done. It's when we jump into the pipeline itself that we start to see this nice little visual builder that allows us to pick and choose how we want to construct the build flow. So in this instance, I have a managed build. We're going to deliver the artifacts and we're going to trigger the deployment. If I wanted to add additional steps, I could add a new stage in serial fashion. I could add a parallel stage. Maybe we're going to build multiple artifacts simultaneously, or maybe we want to deliver to two different artifact repositories. We could do that. We can incorporate a wait if we wanted to kick off the build and then, let's give it 5 or 10 minutes after the build is complete before we move to the next step. That wait could allow us to kind of double check things. Typically early on, if we're starting to kind of feel our way out through this process, this methodology, I want to add a couple of wait stages just so we can kind of watch it, manually perform some checks along the way, and then move from there. So you'll see the build history, and I'd like to say that I purposely caused some of these to fail just because it's more fun to see, learn from our mistakes. But the nice thing, again, all of this is let me actually back up just a minute. So when you create your project, before you create pipelines, you actually have to activate logging. And this actually integrates with the OCI logging service, which covers your entire OCI tenancy. So we create a log group for the DevOps project, the log name for this particular instance. And if we wanted to jump into the log group and see what we're capturing, this, of course, takes us out to the logging service. We can look at the logs themselves. And metrics. Oh, you know what? Hold on. Let's go today. All right. So for today, you can kind of see here for the deployment pipeline. And if I scroll all the way back, there's probably some for my build pipeline. There we go. There's the build. And you can see here, every bit and piece of that build process has been captured in the log file. And from here, from the logging service, I can actually go and create alerts that would trigger based on certain error messages or certain codes that might show up in my log files, and have those alerts start to email me or send me a page or something if there's weird things going on. So that's one of the integration pieces with the overall platform that makes it easy to kind of have a heightened level of visibility into what's going on in the environment. If I go back to my build pipelines really quick, you'll see the build history here. If I do go to look at one of the failed options, you can see here the build ran just fine. That build stage consisted of basically setting up the build runner, downloading my source code from the OCI code repo, and running a set of tasks. And then when we get to the upload artifact, it had an issue. It failed. And I want to know why that happened. We're going to scroll all the way down here to the end. You can see we successfully built the container image, successfully tagged it with the latest image version. And then upload failed. So here, the Rust app base image failed to upload to my container registry. And it took a little troubleshooting here to figure out what was going on. In this case, it turned out it was a permissions issue for me. I had skipped a step in the documentation, which was to give the DevOps service access to the container registry. So it was basically failing to upload because of a permissions issue. So I was able to get that fixed, come back to the next build, and it was so much happier. It was able to prepare and push that image to the container registry. And once the artifact was uploaded, we trigger a deployment. So this basically just kicks off the deployment pipeline, which takes us through the next set of tasks.
You should be seeing deployment pipeline. This is really sort of the introduction to what Eli has already shown you the fact that you can deploy, control, and go through different integrations. You can integrate different aspects of it. You can choose to do blue-green strategy or a canary strategy, or you can write your own strategy, in all frankness, but these are as good as most people need in most circumstances. And you can do integration through evoking a function or execute a shell command, or and of course, if you can evoke a function, you can also send a note. So you can set up a trigger and a notification to make this work for you as well. So Eli has gone through the process of what it looks like to do a project. And here's an example project where you would come in, and I'm sure you all are familiar with this kind of a diagram. In this case, you have 3 different types of servers: a web server, a background server, and a scoring server in this process, and different tools are being utilized to run them and put them in place. And it's just a matter of how you want to make it work. And if you already have CI, CD tools, that's great, because all we're doing is providing you a framework, and that you can, and it's an open framework so that you can easily integrate with them. We have Jenkins. We also have Argo. You can use GitHub. You can use other repositories. You can use your own repository either inside our cloud or on-premise or inside another cloud. It's just simply what works for you, what makes sense for you and your security department, and the latency you're willing to tolerate, depending upon where your different parts of your development team happen to be. So this mentions the Jenkins plugin. As I mentioned, we also have an Argo plugin. So it just depends on what you're familiar with. A lot of folks like the Jenkins tool in particular, with a more standard virtual machine approach and a more SOA approach. But for microservices, I've known a number of different customers have told me, nah, I prefer Argo. So, but it's completely up to you and what your preferences are. Well,
cool. So we looked at the build pipeline, and you can see here, if I wanted to kick this off, I can do a manual run. So we'll just start that process, and it's going to go through. In this case, it's taking about anywhere from 9 to 12 minutes to do the full build. So while that's running, we're going to jump back to our project landing page here and look at a few more things. Before we go to deployment pipelines, though, I wanted to just key in on the environments. So when you get to the deployment part, you do have to tell OCI DevOps where we're going to send the artifacts for deployment. When we create, we're going to have a couple options here. We have OKE, we have functions, and we have the compute instance groups. And the compute instance groups would give us the option, if I had, a cluster of virtual machines, those are contained inside of an instance group, which allows us to deliver a consistent set of configuration and deployment parameters to each resource in that group. We talked about serverless functions a few sessions back as well, so that would be another option if we're building small, lightweight polyglot application functions and we want to send the code there. Or in this case, we're going to be sending it out to the Oracle Container Engine for Kubernetes. We'll just give this a quick sample. And then the next stage here, we get to pick. And so as Lynn mentioned, we can deploy multi-region. So if I had an OKE cluster in, let's say, Phoenix and one in Ashburn, I would simply create 2 different environments. I don't know if I actually have one in Ashburn right now, but let's check. East. There we go. I do have one. So just for fun, we'll point to that. And you can see in the environments here, I have my sample and I have my Rust environment. Now, the other piece here too is the artifacts. The base image was created as part of the build process. The Kubernetes manifest is actually something that I wrote beforehand. We can take a look at it here. It's going to be out. Let's cancel that. It's part of my my Git repo, so it's in my source code. But as part of the build process, we're just going to take that out of the Git repository, and we're going to put it up as an artifact so that my deployment pipeline can consume that to deploy to the specified environments in the deployment pipeline. So I go back over here really quick. Triggers. So I don't have any triggers here, but if we wanted to automatically kick off the build anytime we check in new source code, we could absolutely do that here. So let's see, build from source. We're going to link this to our OCI code repository. And then we're going to add an action. That action is simply to kick off the build pipeline. And anytime we push code, and here we can limit to a particular branch. So only if the code is pushed to main, we can kick that action off. So I'm not going to save this just because I want to maintain the control of manual triggering for now, but that is one of the options. If I go to my deployment pipelines, you'll see a slightly different setup here. So in this case, I have just all we're doing is deploying. Pretty straightforward. However, if I wanted to add a parallel stage, let's say we had those two different OKE clusters, I can deploy to Kubernetes, deploy Ashburn. Oops. We're going to pick the other environment that we created, which is a cluster out in Ashburn. Now here in the deployment, we have the option, do we want to fail back? We want to roll back to the previous successful version if there's an issue. And this is really personal choice. You have to kind of assess the impact. If I don't roll back, if I deploy code or I deploy a container image that's non-functional, is that something I want to just go and fix and try to roll forward? Or do I want the system to automatically just redeploy the previous known good version? We're going to select the manifest from our artifact repository. And then if we have a custom namespace, so in this instance, I actually went out and created a namespace for this, which is the NS Rust sample. So I can just drop that in here. And as it's applying the kubectl commands on the back end, it's going to go ahead and make sure it points at the right namespace. So I would add this stage. And now when I kick off my deployment pipeline from the build pipeline, it's going to automatically execute a deployment to the Phoenix cluster and the Ashburn cluster in parallel. Now, if we wanted to add a little bit more functionality, this is a very basic example, as I'm sure you'll all agree. I can add a new stage here. Once I've done my deployment, I could add a traffic shift. So we've just deployed to two different clusters. Maybe the Ashburn cluster is my canary, so to speak. Now, that's not to say we don't have a canary. But in this case, I've chosen a different approach. I'm deploying to multiple clusters simultaneously. And what I want to go ahead and is, let's see, partial shift. I would pick my load balancer. So this would be something I've deployed previously. It's sitting in front of both clusters. I would be able to then basically control each of the backend sets or the backend groups for the load balancer and tell the load balancer how much traffic to send to each of the locations. So the listener, just port 80, backend port 80, and here we go. So in this instance, I only have two nodes, but you can see here I could pick group A, group B. Group A is going to get, let's see, batch count of, let's say, 25. And then the limit is going to be 50% at a time. So basically, we're going to send a little bit of traffic to A, 25%, and then we're going to ramp that up as time goes by. If anything happens to fail, we can simply stop the deployment, roll back, and be back to good. So that just gives us some other capabilities. And as Lynn mentioned earlier, we also have the integration, so I can run a function. I could use functions to perform additional tasks. Maybe after I've deployed, I want to actually kick off a function that does some basic user testing or functional testing of my API endpoints or my application endpoints. I can also execute a shell, which is going to give me the option to utilize the OCI CLI. I could run a Python script that's going to access the OCI APIs and perform various tasks, or that shell command could be reading from or writing to an external database that's keeping track of our build or our version history for a separate function, separate environment entirely. So a lot of flexibility available there, which I think is pretty slick. If we go back just really quick, I think the build should be just about done. Still in progress. Okay, we're at the upload phase. In the interest of time, I will just show, in this particular example, it's a very basic Rust application. So if I do a kubectl namespace, oops. Of course, what did I call it? Well, yeah, there it is, Rust sample. Give my services. I'm going to have a public IP address here for the load balancer that's sitting in front of the application. So I can just do a curl. And voila. So you'll see here, the response for my application was simply hello world with Rust and Rocket. So I know it's not shiny and fancy and exciting, but you kind of see the whole start to finish process here. If I went back into my source code, I could certainly, make some changes, make it more interesting and exciting, redeploy, and have that new functionality. Well, we have kind of one final topic that's often, top of mind for everybody. I know it is for me. Software supply chain. So, this is really CI/CD DevOps is about delivering, new code. It's our software supply chain. And unfortunately, let's say with great power comes great responsibility, as the attacks on the software supply chain around the world has continued to increase over the years. That statistic on the right always surprises me, that the number of organizations that are experiencing attacks, it's continuously increasing. And these attacks range from all that flat out compromising of the build platform to lack of code signing or poor code signing hygiene, issues with third-party or open source software. And this is not to scare anybody, but just to make sure that we're all thinking about security, full stack security. It's not just network security. It's not just encryption. We want to make sure we incorporate all the different layers of security into our application ecosystem, including that software supply chain. So there's a couple different solutions available. One option within the OCI ecosystem is the vulnerability audits. So for Maven packages currently and others to be released shortly, there's some automated scanning tools that will check dependencies for vulnerabilities. It will take a look as part of the build process. You can define this in your build spec, and it's basically going to check the resulting package before delivering that out to the artifact repository. So if there happen to be any issues, you can actually basically stop the build and go back to the drawing board. We have a number of third-party partners. So this is a bit of a plug for our partner DigiCert. They've been kind of a key player in this space for many years, but they provide a software trust manager, which does not only the signing, but creates software bill of materials, as SBOMs. That is to ensure that what you set out to create and what you delivered match, and nobody snuck in additional libraries or dependencies along the way, or things that weren't being expected. They do that secure code signing so that you can make sure the signature that's included at time of delivery is the one that was actually applied at time of build, and nothing was circumvented or usurped along the way. And last but certainly not least, because obviously this is part of the OCI ecosystem, there's a few other nifty ways you can approach privacy of your DevOps projects and your build runners and things of that nature. So, your code repositories, they're private by default. You can make them public, but you have to ask yourself really why. What is the reason behind that, and is it worth opening up our code to potential malicious actors? Folks may have seen recently the 12.8 million secrets leaked. I won't say any names or any brands, but that's not their fault. It's simply people checking in code with live passwords, with SSH keys and other tokens. It's back to that human error, human nature, right? We overlook something that we've just finished testing. We push it out to a public repo that's on the internet, and there's bad actors out there looking for that kind of thing day and night. So, private code repositories, the build pipelines, the deployment pipelines, of course, are private, isolated. They're blocked away from the public internet. And in the build runner, when you specify the build stage, you can actually deploy that into a VCN, into a private subnet that you have full control for. That way you can control what external access that build runner has, if any. You can control whether the build runner has access to maybe internal config management tools or databases that contain environment information that you want the build runner to access. And then on the Kubernetes side, you can even deploy the OKE cluster and the Kubernetes API in a private subnet. That way, if your application is not directly connected to the internet, or you don't want to have folks outside of your OCI network system or network ecosystem to access the cluster API, you can certainly lock that down and keep it secure and keep it private. So I think from there, the next best thing is to get started. As Lynn mentioned earlier, we have a ton of great resources. There's hands-on labs, there's videos, there's tutorials, and check out the different resources that are available. And with that, hopefully the session has been informative and beneficial. As
I mentioned before, we not only have the documentation, I did in one of the answered questions, we do have a lot of different resources, and part of that is the community that you can find that is also out there. So remember that you do have other folks that are using Oracle all the time, whether it be our data systems or our analytics or even services such as our DevOps that you might be able to query and understand. So there are the developer tutorials, developer's guide, and discussion of different APIs. So if perhaps you don't see one thing that doesn't jump out, you might find that we can merge. Example of this is, for a long time, we had our own proprietary streaming function. Then we went to Kafka type. So now we can talk to everybody's streaming. So you might find that if it's a cloud standard, we do try to comply with those standards now for integration, in particular, in different sources.
We do have our Oracle Cloud World event coming up in November of this year. So you're going to have a lot of the experts from around the world coming in to share their perspective, their expertise, in a wide variety of topics. We're going to have cloud native, we'll have AI, of course. We're going to have enterprise applications and system integration. Basically, if Oracle produces software for it, we'll have our foremost experts there to talk about it. And hopefully it's interesting to folks. You come down to Vegas and join us, and we'd love to hear any other feedback or thoughts, questions along the way.
Thank you for wrapping up the Cloud Native series with this awesome session today. I hope everyone enjoyed the series and learned something new from here. Again, you can watch for recordings on our Day 1 and Beyond page, or the Cloud Customer Connect link that we had shared earlier. Please go ahead and bookmark the Devon and Beyond page so that whatever new series or new topics we add, you will be the first one to know about that. So bookmark and check frequently for new sessions on trending topics that we'll be adding. And with that, thanks again for joining us. And for those who are done, thank you so much for joining us. Have a great day, everyone. And hopefully we'll see you in our next series or next sessions that we have scheduled on our Devon and Beyond pages. Thanks, everyone. Have a great day.